We're now in a position to complete the calculation of the z-scores. In the parts leading up to this one, we entered the IDs for the 5 test takers here. We entered their original scores in column X, column labeled X. We calculated and entered their means in the column labeled mu, or the mean. And we calculated and entered their deviation scores in the column with the script X, symbol for deviation scores. In addition, we took the deviations and then we calculated and entered the squared deviations in a new column, x squared, here. And from those, we then calculated the variance and the standard deviation of the scores. I have placed the standard deviation, 1.095, in the next column. And that's all we need to calculate the z-scores. With this material as background, it's fairly easy to get to a z-score. The formula for a z-score is over here on the left. The z-score formula is such that the z-score equals the obtained score minus the mean of the score over the standard deviation, or even more simply, the z-score simply equals the deviation of the score over the standard deviation. And over here on the right, I've explained each of the individual symbols if you'd like further reference. Now let's apply the z-score formula to the data. To apply the formula, I'm going to take numbers from this column, the deviations, and divide them by the standard deviations. So for example, I'll take the score or the deviation score of participant 1 here, test taker 1, which was -1, and I'm going to divide it by the standard deviation of 1.095. And when I did that, I got a value of -0.913. And that's the z-score for the first test taker. As a second example, for the second test taker, well, the deviation from the mean was 0, so that's a z-score of 0. Pretty straightforward. For the last test taker, the deviation score was 2, test taker number 5. I divide that also by 1.095, the standard deviation, and I get a z-score of 1.826. And by doing that, I get all the z-scores that we need for this set of data. So that's it. We have reconverted our obtained scores, the x's, into z-scores over here. The new z-scores have a mean of 0 and a standard deviation of 1. True, they aren't as pretty as the obtained scores in this case, but by making this conversion, we can readily compare the scores to other z-scaled scores. We can convert the scores to a reporting scale of our choice. That is, we can report them as IQ scores or on an SAT scale or on something called the T-scale that I'll go over later. And we can calculate correlation coefficients fairly readily, starting with z-scores. And that's it.